here today, but hopefully this will help you kind of prepare for that upcoming quiz. So let's go ahead and let's take a look at just simplifying the radicals. So at no point do I want to have decimals. So I want to work on breaking down that radical 125. So what I'm going to do is I see that it ends in 25, so I know it's going to be divisible by 25. So 125 divided by 25 is going to give me 5. So I know that this breaks down to 25 and 5. Well, 25 is going to break down to 5 and 5. So I notice that I could take out a pair of 5s. So on the outside, I'm just going to write that 1 5. And then left underneath the radical is going to be what didn't have a pair, and that was that 5. So my final answer for number 1 is 5 square root of 5. So then we want to take a look at the number 80. So I want to think about what goes into 80. Well, some people divide out 8 and 10, which you could, but I also happen to know that 16 goes into 80. And remember, whenever you can, you want to try and break it into one of those perfect squares. So 80 is actually divisible by 16, and it's going to be 16 and 5. Well, 16 is going to break down to 4 and 4. So what you have here is a pair of 4s that you can take out. So we'll take out the pair of 4s, and left underneath the radical is 5. So you have 4 square root of 5 for your final answer for number 2. Next, let's take a look at number 3. Now, a lot of students on these try to immediately go and rationalize the denominator. But what I actually suggest you do first is simplifying underneath that radical. Okay, so I take 112, and then I have the square root of 175. Well, I'm just going to take a guess that the square root of 125, that 112 is divisible by 4. And it turns out it is, and I get 4 and 28. Well, 28 I can break down into 4 and 7. Now I could take all of those 4s and break them into pairs of 2s, but I do see that I have a pair of 4s there. So I know that I can take out a pair of 4s. So I have that 4 that I'm going to write on the outside, and then what's left without a pair is that 7. So the 7 is going to go underneath the radical. When you take a look at 175, anything that ends in 25, 50, or 75 is immediately going to be divisible by 25, which I know is a pair. So 175 divided by 25 is going to give us 7. So we have 7 and 25. 25 is going to break down into a pair of 5, so I can take that out. So what I'm going to do is write this as the original fraction. So this is going to be divided by 5 over the square root of 7. Now some students immediately just jump into rationalizing the denominator, which you don't have to do because both of these cancel out. So our square roots cancel out, and we're just left with 4/5 as our final answer for number 3. Okay. Next, let's take a look at number 4. So we want to break down that radical. So we're going to take the square root of 24 and break that down, and the square root of 54 and break that down. Well, 24 I can divide into 4 and 6. And 4 is going to break down to 2 and 2. 6 will break down to 2 and 3, but there's going to be no pairs there. So all I'm going to be able to take out is that pair of 2s. 54 will break down to 9 and 6. 9 breaks down to 3 and 3. 6 breaks down to 2 and 3. So I can go ahead and I can take out a pair of 3s. So for this radical here, I'm going to have a pair of 2s on the outside, and left underneath the radical is 6. Then for 54, I can take out a pair of 3s, and left underneath the radical again is 6. So I'm going to cross off those square roots of 6's, and then I'm left with 2/3 as my fraction. So 2/3, and hey email, is my final answer for number 4. Next, let's take a look at number 5. So we want to break down 32 as well as our letter number of p's. So 32 I know is divisible by 16. In fact, it's going to be 16 and 2. Well, 16 is one of our perfect squares, and 16 can break down to 4 and 4. So I'm going to go ahead and I'm going to write some of the radicals. So I have 2 times 4 times 4. Again, I didn't break those 4's down because I already found a pair. And then I have p to the third. Well, that's the same as having 1, 2, 3 p's underneath the radical. And now I'm going to go ahead and find my pairs. I have a pair of 4 here and a pair of p's here. So outside the radical, I'm going to have a 4 and a p. Now remember, when you take it outside of the radical, you do not put it as 16. So when I take out the pair of 4's, it's just going to be 4. And then left underneath the radical is 2p. So I have 4p times the square root of 2p. So let's take a look at 147. So 147 I can divide by 3. Okay, that's what I usually try when I have an odd number and I don't know what goes into it. And that ends up being 4 or 3 and 49. Well, 49 I can break down to 7 and 7. So then underneath my radical I'm going to have 3 times 7 times 7 and 1, 2, 3, 4 different p's. So I have a pair of 7's, a pair of p's, and another pair of p's. So on the outside I have 7 times p, and left underneath the radical is 3. So p times p is going to be p squared. So I have 7p squared square root of 3 as my final answer for number 6. All right, let's take a look at adding and subtracting radicals. So in order for us to add and subtract radicals, we have to have the same number underneath the radical. So I notice that these are both square roots of 6's, which means I can add them together. So 3 square root of 6 minus 4 square root of 6. 3 minus 4 is negative 1. And then we're going to keep the square root of 6 the same. We're not going to actually change it. And negative 1 square root of 6 can also be written as negative square root of 6. I will not take off points if you leave it as that. Both of these are perfectly acceptable answers. Same thing for number 8, negative 10 square root of 7 plus 12 square root of 7. We can actually take those two and add them together because they're both square roots of 7. So negative 10 plus 12 is going to be 2, and then left over is the square root of 7. So I have 2 square root of 7 for number 8. Taking a look at number 9. Now I can't add these together right now because they don't have the same radical. So 3 cannot be simplified down anymore. So what I'm going to try and do is break down 27 to see if I can get something that I can multiply with that, or add or subtract with that 3. So then I'm asking myself, okay, what goes into 27? And that's going to be 3 and 9. And then 9 is going to break down to 3 and 3. So then I can take out a pair of 3's. So I have 3 square root of 3, and then minus, now I'm taking out a pair of 3's from this radical. So I'm going to take out those pair of 3's, and then left underneath the radical is what's not in a pair, and that's that secondary 3. So now I have 3 square root of 3 minus 3 square root of 3. Don't overcomplicate this. What's 3x minus 3x? That's just going to be 0. So 3 square root of 3 minus 3 square root of 3 is just going to be 0 for your final answer for number 9. Let's take a look at number 10. So for number 10, we're going to have to break down each of these radicals to see if we can add something together. So 18 is going to break down to 9 and 2, and 9 is going to break down to 3 and 3. So out of that first radical, I'm going to take out a pair of 3's. Now what I'm going to do here is I'm only going to take out and deal with one radical at a time. I'm not going to put them together until the very end. So this pair of 3's, when I take it out, needs to be multiplied by the 3 that was originally the coefficient. So 3 times 3 is 9, and then left underneath the radical is the square root of 2. Now I'm going to break down 12. Well, 12 breaks down to 4 and 3, and 4 breaks down to 2 and 2. So I could take out a pair of 2's from 12, and when I do that, I need to multiply it by the coefficient that was originally on the outside of the radical. So 3 times 2 is 6, and then left underneath the radical is 3. Then from 27, I can do 9 and 3, and then 9 I can break down to 3 and 3. So I have a pair of 3's here. So I could take out a pair of 3's, and then left underneath the radical is 3. Okay, except, whoops, I forgot to multiply it by that coefficient. So when I take out a pair of 3's, I need to multiply it by the 2 that was originally on the outside, which is 6. So now I can go ahead and I can add like terms. So 6 square root of 3 plus 6 square root of 3. So we're going to have 9, there we go, square root of 2, and then I can add 6 square root of 3 plus 6 square root of 3, which is 12 square root of 3. So this right here is my final answer for number 10. Okay. All right, taking a look at number 11. So these 11 and 12 are going to require us to rationalize the denominator. So the first thing we do when we rationalize the denominator is we're going to split it up. So I split it up into the square root of 3 divided by the square root of 2. Now, I want to get rid of that radical on the bottom. So first thing I'm going to do is check that either radical can be simplified. And in this case, they cannot. So I'm going to go ahead and rationalize the denominator. So what I'm going to do is I'm going to multiply. I have the square root of 2 here. So I'm going to multiply by the square root of 2 over the square root of 2. Okay? So when I multiply by that, okay, it's really the same as multiplying by 1. So then what I'm going to do is I'm going to multiply underneath the radical to underneath the radical. So 3 times 2 is going to give me 6. So here I have the square root of 6. And then on the bottom, the square root of 2 times the square root of 2. When you multiply the same radical times itself, you just end up getting 2. So I have the square root of 6 divided by 2 for my final answer for number 11. Let's take a look at number 12. So I have the square root of 45 and the square root of 27. So I'm going to split those up eventually onto one fraction. But before I do that, I want to simplify the radical. So 45 I can break down to 9 and 5. And 9 I can break down to 3 and 3. So I could take out a pair of 3's and I get 3 square root of 5. For 27, I can break that down into 9 and 3. And then I can break that down to 3 and 3. So I have a pair of 3's that I could take out. So I have 3 square root of 3. So then when I rewrite it as a fraction, I have 3 square root of 5 divided by 3 square root of 3. So I'm going to make my life a little easier. Since both of these are 3's and they're on the outside, they're going to cancel. So now all I have left to deal with are the radicals. So I notice that I have the square root of 3 on the bottom. Since I have the square root of 3 on the bottom, I need to multiply by the square root of 3 over the square root of 3. Alright, so what we want to do is we want to multiply underneath the radical to underneath the radical. Well, 5 times 3 is going to be 15. So that's going to give me the square root of 15. Then when you take and you multiply the square root of 3 times the square root of 3, when you multiply the same radical by itself, you just get that number. And this ends up being your final answer. You can't simplify 15 and 3 because 15 is under the radical and 3 is not. Alright, so moving forward to these multiplication ones. So the first thing we're going to do is we're going to take the square root of 3 and distribute it in. Now remember, when you're multiplying, you can only multiply underneath the radical to underneath the radical. So square root of 3 times square root of 5 is going to be the square root of 15. And then when we go to multiply the second part, pretend there's a little 1 outside of the 3, and that 1 is going to be multiplied by the 2. So that 2 is really just going to stay there on the outside. It can't be multiplied by anything because it doesn't have the same, it doesn't have a number on the outside. Now we take a look, 3 and 6 are both underneath the radical. So 3 can be multiplied by the 6 and you get 18. So we're almost done here. The only thing we have to do is we have to fully simplify, which means we need to break down that 18. So I noticed I could take out a pair of 3's. So I'm going to take out those pair of 3's and they need to be multiplied by my original coefficient. So the square root of 15 is going to stay the same. And then 3 times 2 is going to give me 6. When I take out those pair of 3's, I multiply by the radical on the outside, and then I get the square root of 2. I don't really care what order you write those two in, as long as you have both terms. Now let's take a look at number 14. When you multiply two binomials like this, I always suggest using the box method. So I have the square root of 3 times the square root of 6, and then plus the square root of 6, and then square root of 3 minus the square root of 6. So I lined it up outside the box, and now I'm going to multiply into the box. So square root of 3 times square root of 3, that's going to end up being the square root of 9. Remember, multiplying underneath to underneath. Square root of 3 times square root of 6, well, I can multiply the 6 and the 3 because they're both underneath, and I get 18. Same thing here, I get 18, except notice that negative on the outside, that's going to make this guy negative right here. Square root of 6 times square root of 6, that's going to give me the square root of 36, and again, it's going to be negative. Please, please, please be watching your negatives on this problem. It will make it more challenging for you, and you will make mistakes if you don't be careful of your negatives. So let's go ahead and let's write out our terms. So we have we have the square root of 9 plus the square root of 18 minus the square root of 18 minus the square root of 36. Now, A lot of people at this point actually try and simplify the square root of 18, but notice we have plus square root of 18 and minus square root of 18. So those are actually going to cancel out. And let's think about this logically. What's the square root of 9? Well, the square root of 9 is just 3. And what's the square root of 36? Well, that's going to be 6. Now notice that we're subtracting off the square root of 36, so we need to subtract off our 9. And 3 minus 6 is negative 3. So our final answer for that one is negative 3. All right, last but not least are these review problems. So it asks you to solve using the zero product property. If you want to use the quadratic formula here, you're more than welcome to, but the zero product property does work on this one. So to do that, you're going to multiply the first and the last, and you're going to get a negative 56 here. A negative 56 adding to a negative 10. So we're asking ourselves what multiplies to a negative 56 and adds to a negative 10. We're going to have a negative and a positive sign on each side, okay, because we're multiplying to a negative product. I'm going to use 14 and 4, and I want the 14 to be negative because my sum is negative. So now I'm going to use those factors to split up my negative 10. So I have 7p squared minus 14p plus 4p minus 8 is equal to 0. Okay, so now I'm ready to factor this by grouping. So since I have 4 terms, I'm going to factor by grouping, which means I'm going to make 2 groups. Out of the first group, between 7 and 14, you can divide out a 7, and you can also take out a p. So I'm going to go through and divide each of these by 7p. And then I'm left with p minus 2. Then out of my second group, I can take out from each term a 4. So I'm taking a 4 because each of those terms are divisible by 4. And then 4 divided by 4 is just going to give me p. And then negative 8 divided by 4 is negative 2. And that's equal to 0. So we have 2 factors here. We have p minus 2, and then we have 7p plus 4, and that's going to be equal to 0. Okay, so then we want to take and now at this point we need to set each of these factors equal to 0. So p minus 2 is equal to 0 and 7p plus 4 is equal to 0. And then once we've got it set up like this, it's just going to be solved like a normal equation. So we're going to do, for this one, add 2 to both sides and you get that p is equal to 2. For this next one, subtract 4 from both sides. And then you get 7p is equal to a negative 4. And then you're going to go ahead and you're going to divide both sides by 7. And when you do that, you end up getting p is equal to negative 4/7. You can leave it as that, or you could divide it out to get your decimal. Either is fine with me. Okay? Next, let's go ahead and let's take a look at number 16. So for number 16, you're going to set up your x. You're going to do 10 times negative 3, which is negative 30, and adding to 13. A lot of students here want to use 10 and 3, but you can't because we need to get a negative product. So we need a positive and a negative factor. So what you need to use is 15 and 2. So then we have 10d squared plus 15d minus 2d minus 3. And eventually that's going to be equal to 0, but I kind of ran out of space, so we're going to hold off for that just for a second. And I apologize, my computer is having a hard time keeping up with me here. So now I'm ready to factor by grouping. So what I'm going to do now is I'm going to make my 2 groups. So then when we make our 2 groups, here we go. So between 10 and 15, you can take out a 5 and a d. And then you're left with 2d plus 3. Now, out of the second group, you cannot take anything out. But I do notice that the middle sign is negative, so I need to take out a negative. And what I'm going to do is take out a negative 1. And that's going to change it to be 2d plus 3, which is good because then our factors match. And once our factors match, we can write it out, 2d plus 3, and then 5d minus 1, and that's equal to 0. So from here, we can take and we can set each of these factors equal to 0. So 2d plus 3 is equal to 0, and 5d minus 1 is equal to 0. So when you solve those, you end up getting that d is equal to a negative 3/2 and 1 over 5. Again, you can use the quadratic formula to solve this if you so choose. Okay, so it does conclude this review, so you can go ahead and show the sub that you have the review done to get the quiz. Again, in order to take the quiz, you do need to have all of your practice sheets completed. If you don't, I won't grade it. Okay, thanks for listening.